Welcome back to the AI Smoke Session. In the last episode, we built a deep learning system that could detect cannabis leaf diseases using computer vision. But what if artificial intelligence could go even further? What if AI could predict your harvest weeks before it happens? Imagine being able to estimate how much yield a plant will produce while it's still growing. In this video, we're going to build a machine learning model that predicts cannabis harvest yield using cultivation data. And along the way, we'll also discover which factors influence yield the most. So instead of just talking about artificial intelligence in cultivation, we're actually going to build part of the system. Let's get started. The first step in any machine learning project is data. For this demonstration, I'm working in Google Colab, which is a cloud-based notebook environment that allows us to run Python and machine learning workflows directly in the browser. Inside the notebook, we create a dataset that represents variables commonly found in cannabis cultivation. These include environmental and plant growth factors such as temperature, humidity, and light intensity, nutrient levels, plant height, and the number of days the plant has been growing. These variables become the input features. The goal is to predict one important value: harvest yield per plant. Because we are predicting a numerical value rather than a category, this type of problem is called regression. Regression models are widely used in agriculture to estimate crop yields and forecast production. After generating the dataset, the next step is preparing it for training. We separate the data into two parts: input features and the target variable. Next, we split the dataset into a training set and a testing set. The training data is used to teach the model the relationships between environmental variables and yield. The testing data is used to evaluate how well the model performs on new examples it has never seen before. This ensures the model is learning real patterns rather than simply memorizing the dataset. To begin the modeling process, we start with a linear regression model. Linear regression is one of the simplest machine learning algorithms. It attempts to find a mathematical relationship between the input variables and the predicted output. During training, the model adjusts its internal parameters to minimize prediction error. Once training is complete, the model can estimate cannabis yields based on growth metrics. This gives us a useful baseline for understanding how the data behaves. But cultivation environments are rarely perfectly linear. Factors interact in complex ways, and this is where we can improve our model. Next, we introduce a random forest regressor. Random forest models work by building many decision trees and combining their predictions. Each tree learns different patterns, and together they form a stronger prediction system. Because they capture nonlinear relationships, they are often more accurate for real-world data. After training the random forest model, we can evaluate its performance using the testing dataset. First is mean absolute error, measuring the average difference between predicted and actual values. Second is the R-squared score, which tells us how well the model explains variation in the data. Comparing the linear and random forest models shows which approach is more accurate. One of the most interesting things is that random forests reveal feature importance. It helps answer, which environmental or plant factors have the greatest influence on yield? When we plot the chart, we can see which variables the model relied on the most. For example, plant height and light intensity might appear as strong predictors of yield. This allows growers to understand which variables are most strongly associated with outcomes. Instead of guessing which conditions matter most, ML reveals the patterns hidden inside the data. By plotting actual versus predicted yields, we see how closely the estimates match real values. If points cluster along the diagonal, the model is making accurate predictions. This confirms the system is capturing meaningful relationships within the cultivation data. Finally, we test the model with a completely new example. The model estimates the expected harvest yield, giving us a predicted value in grams. This is the foundation of predictive cultivation analytics. A system like this could eventually provide growers with early yield forecasts. That means cultivation teams could adjust settings long before harvest time. Machine learning is beginning to transform agriculture by turning raw data into predictive insights. For cannabis, this means forecasting yields and optimizing environmental conditions. While this is a demonstration, these concepts are already being explored in modern research. As technology evolves, AI will play an increasingly important role in data-driven decisions. And that's exactly what this series is about: applying AI to real cultivation challenges. Next time, we'll explore how computer vision models can analyze plant health and growth stages automatically. Until next time, stay curious, stay informed, and keep exploring the future of AI. Stay curious, stay informed, and keep exploring the future of AI.